Hi, and thank you for your question. So for this question, we are looking at water. Just going to clear up a little bit. And we're given that the mass of water is 2,890 grams of water. So I'm going to put here as H2O. We know that the heat that's given off is that's applied, I should say, is 5.41 times 10 to the power of 5 joules. So that's the amount of heat that's being applied to this sample of water. We also are looking for, we're given those two pieces of information, we're looking for the initial temperature of the water, and that we don't know. So that's going to be in degrees Celsius. That's the data that's given to us, but we do know that the specific heat capacity of water, or C, in the specific heat capacity equation, this constant for water is 4.18 joules per gram per degree Celsius. And it also says in the question that the water's brought to the boiling point, and the boiling point for water is 100 degrees Celsius. So we'd have to look up these two constants, our heat capacity for water and also the boiling point for water. So just a little bit more information is given here. Having this, we can now apply this to our heat capacity formula, which says that the amount of heat that is added is going to be equal to the mass of the water times its specific heat capacity times its change in temperature. So I'm going to go ahead and add my information in. Q is equal to 5.41 times 10 to the 5 joules is equal to my mass, which I can keep as grams, times my heat capacity, which is 4.18 joules per grams per degree Celsius, and then times my change in temperature. I'm going to leave my change in temperature out first because I actually need that to figure out my initial temperature, because change in temperature is equal to T final subtract my T initial. So instead of putting that in here, I'm just going to leave it. I'll add it in a little bit, because what I need to do is I need to isolate my formula with change in temperature, rearrange it by bringing these two data over to this side. So I'm trying to isolate my change in temperature by bringing this data over. So the first thing I want to do is I'm actually going to combine these two numbers following the operation, which is multiplication. So when I multiply 2,890 by 4.18, I get this. I get 12,080.2 times by my change in temperature is equal to 5.41 times 10 to the 5 joules. Now that I have that combined in this number, I'm now going to bring it over to the other side by doing the opposite operation to what's happening here, which is multiplication. So the opposite of multiplication is division. So I'm going to divide by 12,080.2. That cancels that out, leaving my change in temperature over this side. But whatever I do to this side, I also have to do to this side. So I have to divide 5.41 times 10 to the 5 by 12080.2. Now you might be wondering, well, how do I put this in my calculator? Well, what you do is you just don't worry about the times 10 to the 5th. You're just going to bring that down. But in your calculator, you're going to put 5.41 divided by 12,080.2. And that's going to give you a very small number that looks like this. There we go. So 0.00044784 times 10 to the 5th equals the change in temperature. And now I'm going to move my decimal according to my 10 to the power 5. So 10 to the power 5 means move my decimal 5 places. 1, 2, 3, 4, 5. So that means I'm going to place my decimal here based on this positive exponent. So my answer for my change in temperature is going to be 44.784 degrees Celsius equals my change in temperature. Now that I have my change in temperature, I can put it over here to solve for Ti. I have 44.784 degrees Celsius is equal to my final, which is 100 degrees Celsius, minus Ti. So now I have to rearrange this equation. If I'm subtracting Ti, what I'm going to do is bring the Ti over to this side and bring my 44.784 over to this side. So I'm going to add Ti here. That will get rid of my initial temperature there. I'm also going to add it over on this side. And that's going to give me 44.784 plus Ti equals 100. And now I'm going to bring this 44.784 over to this side by subtracting it from both sides. So I'm going to subtract it from this side and subtract it from this side. That gets rid of that, leaving just my initial temperature here. And 100 minus 44.784 is equal to 55.216 degrees Celsius. And then I'm just going to go by my significant digits here. I'm giving 3 significant digits with my heat capacity here as being the least number. So I will do this to 55.2 degrees Celsius as my initial temperature. So for this, you did need to know that you had to look up the constant for specific heat capacity of water. You also had to know that in bringing it up to a boiling point, that's going to be your final temperature. So that's the first key in solving this question. The second key in solving the question is setting up the heat capacity formula correctly and solving for change in T. Once you had change in T, you're going to put that into the change in temperature equation, and you're going to solve for the initial temperature. So lots of different steps here, just trying to tease out this initial temperature. So I hope this helps. Thanks for your question. Bye for now.